Dear students, now we'll start with the topic, that is conversion from PDA to CFG. Okay, so when I want to convert a given PDA to CFG, I should first understand what are the rules that I'm following for that. So suppose if a PDA is given to me, so I can just write down the PDA tuple definition as the 6 tuples, out of which the sigma indicates the input symbol. Okay, so say for example I have P and Q as the input symbol and tau indicates the tape alphabet. So in the tape I have X and Z0. Okay, so if I'm going to create a matching CFG or a context free grammar for the same. So context free grammar is something which needs a 4 tuples, that is VTPS, where V stands for variable. In this variable you may have a start symbol S. Okay, and some another variables, those variables or the non-terminals can be derived from the given PDA using this particular thing. So I am just writing a particular variable name enclosed in a square bracket, that is PXQ, where P and Q are any of the two input symbols. As you can see, they are taken from the input symbols, and inside them I write one of the tape symbol, that is X, which is taken from this tau. Okay, so this way we make the variables for the given context free grammar. And then how we make the production rules. So context free grammar has something called as a production rules. So those production rules, I make the first production rule with a start state. Okay, that is by default. So how do we do? A start state will give you starting state. Okay, say for example your starting state is Q0. Okay, so you say from Q0, and then here inside there will be some tape symbol. So by default tape symbol is Z0. So default tape symbol, start state, default state symbol, and followed by whatever number of input symbols you have. So I have here two of them, that is P and Q. That's why for P I have done this 1 and for Q I have done this 2. So now I have made these two production rules coming out from S. Okay, that we have to do by default for all the input symbols, that is sigma, that we have in our PDA. So I hope this is clear. Okay, then after that, what are the other type of production rules? The second type of production rule that we can make is when I have some production rules, that is sigma Q on some input symbol A, X is a tape symbol, then it goes to some another state, yeah, R. So Q is a state, R is a state. Okay, on R it goes, what it does, it can push Y1 to YK on the stack top. So how do I replace this particular transition with the production rule? So here you can see this particular line shows us the production rule. This entirely is a production rule. Okay, so how we have got this production rule? Now let's try to understand. This is really very important. Okay, the production rule consists of this thing as well. Yeah. Okay, so what I'm doing is there is this arrow which is very important. So left to the arrow, what do I have? The first thing is the Q that is coming directly from here. Second thing is a tape symbol. So what is a tape symbol? X. And then the output state from Q on reading X, it goes to output state. So that is the output state is this. So I'm taking from R. Okay. So now on the right hand side, the first symbol will always come is something that we read from the string. What we read from the string? A here. So that's why this A comes over here. And now after A, what I should be writing? So that is, I have Y1 to YK. So for every Y, there is one square bracket. Yeah, or one variable that is happening. So I will just write down Y1, Y2, Y dot till YK. Then how do I surround them? I have to surround them with some variable names. So which variable name I'll give? I will give R. Okay, because here on the right hand side I have R. So I start with the R. And I have to finish with I cannot just continue with the same variable. So what I'm doing is I'm saying R to R1, then R1 to R2. So I'm just taking it in a continuation. Yeah. So at the last for YK it is k minus 1 to rk. Like that I can simply show it. And then the third type of production rules. So that means third type of production rules are something where you have this. If you see, just observe the second and third closely. What is the difference? Difference is in right hand side. Over there right hand side has y1 to yk, but here right hand side is a epsilon. So when your right hand side is epsilon, I can say epsilon on right hand side, how do you handle it? So what do? This will come exactly same as we done upper there. That is Q is coming directly. This is a tape symbol coming directly. This R coming directly here. This A goes directly there. Okay. And now after A I have written y1 to yk. But here in place of y to l I have epsilon. That means epsilon, writing epsilon here is nothing. That means it is same as just writing it as a A. So I am just avoid writing this epsilon. Okay, so this is third type of a production rule that we can make. There is a last type of a production rule that we can make with the transition is that here we have a epsilon, but if you see, epsilon is coming on the input symbol as well as the in the right hand side also. So epsilon coming on left hand side as well as right hand side. How do you handle this type of it? Yeah. So again Q is writing here, X is taken here, R is taken here directly. Now this epsilon coming out over here. So that's why I have written it as epsilon, and for this epsilon I am not writing anything. That means it's just a single epsilon. So any type of a PDA, if I want to convert it to CFG, there are two things that I should be doing. Yeah, the first thing that I should be doing is I will write down all the variable names. This is the first thing. I will write down all the variable names, and the second thing is that I will write down all the productions. So when I am writing the productions, they comes in four types. First type, start state. Second type, where you have a symbol, the transitions where we have y1 to yk on the right hand side. Third, when we have epsilon on the right hand side. Fourth, when we have epsilon on left and right hand side both. So we have seen how do we handle all of them. Now let's take an example and try to solve it. So now this is the example given to us. Convert the given PDA to CFG. I have given all the transition rules. So if I just write down the tuple definition of PDA, so there are 6 tuples, and if I write down what are the states in my PDA are there, so we can easily make out Q0 and Q1 are the two states that I am using. So I have written. What are the input symbols I am using here? So you can easily make out it is A and B. What are the tau symbols? Is a symbol on the tape. So on tape I am having only X and Z. So looking at all this, I just find out what is my PDA is like. Now I will just write down what is my grammar will be like. So grammar will have something as a VTPS. So among that I will first identify all the variables. So variables is nothing but start symbol coming first, then all the other symbols. So all the other symbols will have what? Will have all your tape symbols. So what are the tape symbols that I have? I have X and Z. Okay. So now for X, I am writing X. Why I am writing X 4 times? Because of the number of states. Here I have 2 number of states. So if you say 2 raised to 2 is giving me 4. So it is coming with the 4 combinations. And that's why for every single symbol, there will be 4 combinations of states. And that's why for single symbol X, I am writing 4 boxes. Okay. Similarly for Z also I am writing 4 boxes. Now how I am enclosing it? So for X on both the side, I should be writing some state number. So say for example Q0. So I can say if it is 2-digit symbol in binary, we write 0001 1011. Similarly Q00, Q01, Q10 and Q11. Similarly for Z, Q00, 01, 10, 11. So I hope you understood how I have written all the states. Okay, if I have another symbol X, Y, Z, so again there will be 4 new boxes. If I have more states here Q0, Q1, Q2, then I will have that many combinations. So I can say it will be 2 raised to 3, then that many combinations I should be trying out over there for each of the symbol. Yeah. So that is done now. So we have find out all the variables that we require. Then we will write down all the production rules that we will need. Okay. So now let's write down the first type of a production rule that starts with the start symbol. So how do I write? Start symbol gives Q0 as the initial state, Z0 as a stack symbol. So this particular format is fixed. Then I will write down whatever number of states I have. So I have two states here, Q0, Q1, and that's why I am writing it as a Q0, Q1. So I have done with the first type of a production rules. Then second type of a production rules, where we have something called as a Y1 to YK on the right hand side. So if you see this particular production rule, you have some symbols on the right hand side. These are nothing but some tape symbols. You see here, these are the tape symbols, tau. Okay, so whenever you have a production rule, now I have all these transition functions. If you just observe the right hand side of all the productions, all the transitions. Yeah, so what is this having? All those are having tape symbols. Tape symbols is nothing but X and Z. Yeah, so X and Z are nothing but I am doing some push operation here. So push X and Z on the stack. Push XX on top of stack. Here I am push Z on top of stack. But whenever I have epsilon here, what does it mean? Epsilon means pop. Okay, so these transitions are divided into two types. Some are push type and some are pop type. So I will first write down all the transitions which are of type push. So all the transitions which are of type push will be of form Y1, Y2 till YK. Are you following this? Okay, the similar one that we have seen here in the rule number 2. Y1 to YK are nothing but the rules which are of, you can just easily make out from here. This one, yeah. So this type of a rules where we have Y1 to YK, I can say they are of this push type of operations. So here, after identifying all the start symbols, the second type that I am doing is I am identifying all the push operations. So I am writing one transition which is of type push. So the first transition that I have written is Q0AZ and Q0XZ. You see here the first push operation that I have, Q0AZ, Q0XZ. Now how do I write it? As I told you, we should write this Q0 here, Z here and this Q0 here. That is done. Now this A will go on the right hand side. Now what is after A? X and Z. Though there are two symbols or two tape symbols, I will write X and Z in two separate boxes. Now this is one particular transition is production rule is not sufficient because I have a combination of two states, that is Q0 and Q1. Though there are two states, there will be 2 raised to 2, 4 particular combinations available. And that's why I am making 4 combinations over here, and that's why I am writing it 4 number of times, if you can see. So what I am changing in this 4 times, okay, please observe carefully. So what I am keeping common is, yeah, so what I am keeping common is this Q0 is common because this is starting from Q0, that is fixed for the entire rule. Starting and then what is a stack top? Is a Z, that is also fixed. On which input symbol are you taking it? A, that is also fixed. Where is it going? On A, first it goes to X and then Z. So that is also fixed. Now what is variable is just Q0, Q1 that are coming in the combinations. Now what is happening in the variable part? So I have to check the combinations of Q0, Q1. So I will say first 2 I am writing for Q0, second 2 I am writing for Q1. Okay, so first 2 for Q0, second 2 for Q1. So the first 2 are for Q0, right? This and this both are for Q0. So one of them I'll try for Q0, one of them I'll try for Q1. And that's why I will write down this one for Q0, this one for Q1. Out of this 2, Q1, one for Q0, one for Q1. So I hope you understood why I got this. This particular line is all having Q0, that is taken directly from this line. So whatever is starting here, the same starting is here. Okay. Now, whatever is I am writing here should be similar over in the next symbols start. Okay, so the start of next is exactly same. So if it is Q0, Q0, Q1, Q1, Q0, Q0, Q1, Q1. Are you getting it? Now how should I end it? So whatever is there at the end of the left hand side is there at the end of the right hand side. That is Q0, Q0, Q1, Q1. So Q0, Q0, Q1, Q1. So is that clear now? Okay. So this is how I have written all the 4 types of production rules. So here in this case, for one transition function, I am writing 4 production rules because any of them is possible. That is only because this is push type of a operation. Second push type of operation if I see is this. Q0 on AX goes XX. So I'll write it same way. Q0 on AX goes to XX. Now I'll just explain you in very short. So this Q0 is coming here, which is there for all. This X is coming here, which is there for all. Okay. This A is going there, which is there common for all. This double X in the right hand side is double X on both the places. Now here I have first 2 as Q0, second 2 as Q1. Okay, this is taken same as this, all Q0. Now for the first 2 Q0s over here, I have written 1 as Q0, 1 is Q1. 1 is Q0, 1 is Q1. This column you copy exactly the same way. And this last column is exactly the same as last one. Okay, again the third type of a push operation that I have over here is this. AZ on Z. So Q1 AZ, Q0 AZ, Q0 Z. So what will I write here? Again this Q0 is same, this Z is coming here, this A is going here, this Q0 is coming here. So for this Q0 this is same. Here I will try 2 different combinations, that's why there are 2 different rules. Okay. Now here why I have done 2 and not 4? Let me give you that explanation first. Earlier in this particular type of a transition, what we had over here is, here we had 2 symbols. In the right hand side, I had 2 symbols. Now here in the right hand side, I have only 1 tape symbol. So if it is a 1, I will do 2 raised to 1 is equal to 2. And that's why I need only 2 particular rules. So I am writing here A and then ZZ in between. So it is just Q0 and Q1. So start is same and end is same. That's it. Okay, so now I have done with all the push operations that were given here. Now I'll try with the pop operation. The first of our operation is Q0AZ on epsilon. So let's write down that third type of a transition. So for all the production rules which is having pop operation, Q0AZ on Q0 epsilon. How do I do it? Okay, so now this type of operations we will have only one production rule for one transition. Now what is the transition that I have? So we can say that for Q0, I have written Q0, this Z coming here, this Q0 coming here, this A going here. And for this epsilon, I am not writing anything over here. So it is done. Second type of a pop operation that I have is this. Again Q0 taken here, stack top is taken here, this Q1 taken here, this B is taken here, this epsilon need not to be written, so I am done. Now next is this particular pop operation. Here we also, this B going here, this Q1 coming here. For this epsilon, I need not to write anything and I am done with it. So with this 3 epsilon type of a transitions, we can see 1, 2 and 3. I am done with all the transitions. So I can say we can stop now. Okay. So this is how we have solved the example. Let me just give you a review about what exactly we have done here in this particular example. Okay. So very first what we have done is, I have given the particular question of PDA. What I did is, I have written my PDA, I identify what are my states, input symbol and tape symbol. Then I have written what is the required grammar. I will identify only 2 things, that is V and P, that is very important. Terminal and S you will easily identify. So V I am finding with this particular symbol, okay, way. And for finding P or the production, there are three different types I'm using. Actually, four different types. The first type is writing only start symbols, which I have done here. Second is for the production, which is having push operation. So all those which is having push operation is, right hand side we have some tape symbols there. Those are done. Then third is the production which are having pop operation, that is epsilon on the right hand side. Okay. So here all the operations we having epsilon on the right hand side. Okay. Fourth type is something where we have epsilon on both left hand side as well as right hand side. But actually in this question we don't have any such type of a transition. That's why we simply skip that step. Here we have everywhere this A or B coming. Now if any of them is epsilon, then we have epsilon on both left and right. So in that case we would have taken the fourth case, but that is not in this particular question. So that's what we have done. We identified all the V, we have identified all the P. T is nothing but terminal symbol, which is nothing but small a, small v. And S is nothing but your start state, which is nothing but start that we have S we have given. Okay, so with this we have solved this example. Hope you have understood. If you have any doubts, please ask me in the comment box below. Thank you for watching.